Algebra 2, target 39. I can use the unit circle to evaluate trig functions for any number. Today the focus is on using reference angles. So first off, what is a reference angle? Well, a reference angle, it's related to the angle, it's telling us how far away we are from the horizontal. So in this first image, our reference angle, our angle goes here, and our reference angle is how far we are from the horizontal. Our reference angle is right there. That's if we have a second quadrant angle. If we have a third quadrant angle, how far away are we from the horizontal? It would be just this distance here. And if we rotate into the fourth quadrant, this right here is our reference angle. How far are we away from the horizontal? And obviously, if we're in the first quadrant, your angle and your reference angle are the same. To find your reference angle, you're going to want to just see how far away from the horizontal are we. You're going to be either subtracting from 180 or 360 in some way. If you're in degrees, you're going to be subtracting from pi. Now, if it's written appropriately in degrees, it becomes a very easy problem. All right, so let's look. Finding a reference angle. If the angle is 5 pi over 3, if we kind of draw out 5 pi over 3, we see it's pretty close to 6 pi over 3, which would be a full rotation, because that reduces to 2 pi. So 5 pi over 3 fits into the angle, is this angle right here. We're looking for our reference angle. You could do 2 pi minus 5 pi over 3. 2 pi, that's the same as 6 pi over 3, so we have common denominators. Then we're left with pi over 3. Pi over 3 is the reference angle. That's the long way. The quick way, and it's really simple, the numerator should only have pi in it. Pi over 3 ends up being a reference angle. So if you're in radians, your reference angles are very easy to find. Just get rid of anything in the numerator except for pi, and it's pi over 3. For b, negative 130, we'll sketch that out. Go down negative 130 degrees right here in the third quadrant. And what we're looking for then is this distance right there. Well, this is negative 130. How far does it take to come down and meet that line? Well, that would be 50 degrees. That would complete the 180 on the bottom there. All right. Now, if we're going to use our reference angles to find these trig functions, there's a couple things we need to do to use the reference angle and do any angle. First, we need to be able to assign a sign to our trig. As you found in the first quadrant, all trig functions are positive. Now, as we rotate around to the second quadrant, remember sine in a unit circle is just y. Cosine is just x. Well, as we move to the second quadrant, the x values become negative. So that's why in the second quadrant, our cosines are negative. Right? Our sines are positive because the y's are positive. And then tangent, as we kind of talked about, is y over x. A positive divided by a negative is a negative. All right. In quadrant 3, we continue our rotation. X is negative. Y also becomes negative, so that's why sine and cosine are negative. And then y over x, negative divided by negative, that's why that's positive. Continue our rotations over here. X becomes positive. Y is still negative. X is positive. A negative divided by a positive is a negative. So you just need to know this chart. A quick, easy way I know, or I have, for me anyway, of knowing this chart is ACTS. A-C-T-S. ACTS. Fill that in. All are positive. Cosine is positive. Tangent and sine are positive. A-C-T-S, rotating backwards, will tell you what's positive in each quadrant. The second thing we need is we need this chart. We need to memorize this chart so that we know what the exact values are. Now these are the exact values in degrees. Right? Sine of 30 is 1/2, always is, has been, always will be. Cosine of 45 is square root of 2 over 2, always has been, always will be. Take some time to memorize this chart. A few quick hints as far as looking at this chart. Those two values are always the same. Those two values are always the same. And those two values are always the same. Right? So if you just memorize this column, you can get this column by flipping it upside down. And then these are easy. You just take these and flip them to get these, and they rationalize there. All right? And to get tangent, tangent is y over x. Well, sine is y. Cosine is x. You're just going to take these two values and divide them. It's more apparent down here. You take the first value, divide by the second value. The 2's cancel. Square root of 3 over 1 is square root of 3. And our last column, we take and flip the tangent column. All right? So now that we've done that, let's go through and find some trig values. All right? So, evaluate tangent of negative 240. Let's first draw that out. Tangent of negative 240. Here's negative 240. Ends up being in the third quadrant. This line is 180. This line is 270. We come around. How far beyond 180 are we? Well, this is 60 degrees. Right? So really, we're looking for the tangent of 60 degrees. If we go back to our chart, the tangent of 60 degrees is the square root of 3. So the tangent of 60 degrees is the square root of 3. The tangent of negative 240 degrees is also going to be square root of 3, but then we need to make sure we get the right sign. So we go back, we look at the second quadrant, and in the second quadrant, tangent is negative. So the tangent of negative 240 degrees is negative square root of 3. Because it's in the second quadrant and because its reference angle is 60. Now for cosecant. Cosecant of 17 pi over 6. That is almost 18 pi over 6, which would put us at 3 pi. This is 0. This is pi. That's 2 pi. So back over here would be 3 pi. So we go around a full rotation and then a little bit more, puts us in the second quadrant. Reference angle, make it real easy, is pi over 6. So we're looking for the cosecant of 17 pi over 6. All right, that's going to be similar to the cosecant of pi over 6 if we go back to this chart. Make sure you know these values in radians. It goes pi over 6 is 30 degrees. Pi over 4 is 45 degrees, and pi over 3 is 60 degrees. All right, and we were looking for cosecant of pi over 6 is 2. And we're in the second quadrant, so if we go to the second quadrant and check out cosecant is positive. So this is positive 2. All right, sketch the angle, find its reference angle. Pause, try it on your own, and then we'll go through it. All right, 210 is just past 180, so it goes into the third quadrant. How far away from 180 is 210? Well, 210 minus 180 is 30 degrees. All right. Number 6, negative 260 is almost 270, but not quite. Remember, we're going backwards. So how far is it from here? Well, if it was negative 270, it would be 90 away. We're a little bit off. So The reference angle here is 90 or 80 degrees. All right, number 7, we are operating backwards. Negative 7 pi over 9. That actually will leave us right here. This reference angle is 7 pi over 9. Because it's less than the denominator, we don't use that trick where we just do pi over 9. Number 18, 15 pi over 4. Well, 3 pi would be 12 pi over 4. 16 pi over 4 would be 4 pi, so it's going to put us in this quadrant. And our reference angle is pi over 4. All right, evaluate without using a calculator. Cosine of negative 210 degrees. We will start by drawing it out. Negative 210 is going to put us into the second quadrant. All right. How far away from 180 are we? Well, we are 30 degrees away from 180, so the cosine of negative 210 degrees is going to have the same value as the cosine of 30. Cosine of 30, for those of you that don't know it yet, is square root of 3 over 2. And the sine acts, sine is positive in there, so cosine is negative. So the cosine of negative 210 degrees is negative square root of 3 over 2. All right, so in conclusion, what is a reference angle? A reference angle is the distance an angle is from the horizontal. Either the positive x-axis or the negative x-axis. And how do we use it? We use it to find the numerical value of the sine, cosine, and tangents. And then we look at a chart to find out whether it's positive or negative. Because the sine of 5 pi over 3 has the same numerical equivalent of pi over 3. Because it has the same reference angle.